Hello class, today I'm going to start new section for the ANSYS analysis, which is going to be explicit dynamic analysis. Let's see what I have prepared for first video. Today I'm going to show you how we can have explicit dynamic analysis for investigating a bar made of concrete with some reinforcement. So reinforcing bars are going to be stainless steel, and the block is going to be a concrete, and that block of concrete is going to be over two support and another object I'm going to use to apply force at the center. So what I did, I start drawing those geometries in SolidWorks, as you can see here. This is a block of concrete I have, and then this is a rebar I'm going to put inside. As you can see, they're not uniform. I just draw some wire inside. These are just lines, so when I'm going into ANSYS, it is going to ask me, give me some cross-sectional area for these. Okay, I'm going to do that later. And this is the part I draw as a support and applying force. Just so I'm going to put two of them under the concrete bar and one of them at the top, and the one on the top is going to have a velocity and create an impact over concrete. Okay, let's start with explicit dynamics. Let me tell you, when we have a high impact, we usually go for explicit dynamics because it's a faster and it's better choice. But when the velocity is very slow and very small number, we usually go for static structural, which every calculation is implicit. As you remember, we were checking for the force convergence. You saw how implicitly ANSYS solves and converges the solution. Here we are going to have explicit calculations. So let's see, I'm going to drag explicit dynamics here, and let's start with materials. I'm going to open engineering data sources. If we check the list we have, we need to see explicit materials, as you can see here. So we have a lot of different materials here: aluminum, copper, brass, and we have concrete. We have several types of concrete here. If you have model for your own concrete, you can bring it and edit the concrete. I'm going to use this concrete, 35 megapascal concrete. So I'm going to add to the materials. Okay, so two materials for me would be enough: structural steel for the supports and rebars, and this one, the concrete one, for the block of concrete. Okay, let's go for geometry. I showed you the geometry, and so I don't want to draw from the beginning, and it's time consuming, and it was much easier for me to draw in SolidWorks than Space Clay. So let's browse, and this is AP11, and this is the file I saved. So let me open and show you the file, the geometry file we have. So this is our concrete block, and if I hide the block, you are going to see the rebars. I just put inside, they're not uniform, I just draw the rebar network. And this is the part I'm going to use for the apply the impact, and the other two are going to be our support. I just manually adjusted them so they're not at the center, so after simulation we may see we don't have symmetry of the results. For example, this side may have higher stress than the other side because the force is closer to the right side. Anyway, and you can see we have beams because I converted, this is my beams. I converted all these wires, all these lines to beams, and let me show you what is the specification of that beams. When I say specification, I mean the cross-section area. Let's open it. It's circular and the radius is 3 millimeter. Okay, I just wanted to be visually okay. So this is our concrete, 2 supports, and this one is going to be used for applying load. Done. As you can see, I have 3 part 4 to copy and use these places. Why you're not closing it? Okay, closed. Let's open model. We can have a lot of interesting videos using this explicit dynamics, because we can have movement and impact with different velocities, and there are a lot of applications for this. Okay, this is upside down. Now this is our geometry. Okay, let's open the geometry. This one is going to be concrete, so let's select the material, concrete 35 megapascal, and the rest is going to be stainless steel. So the supports plus rebars. So I'm going to click the first one, press the shift button and click the last one. So all of them are going to be structured steel. Let me check, they're already structured steel, so as a default they're structured steel. Even these bars are structured steel, so I just needed to change this one to concrete. Let me close the geometry, so I assign the material. Let's see, we have a connection here and we have body interactions. When we are using explicit dynamics, it is the body interaction part is going to automatically check if we had bodies in contact, it is going to be detect. So usually we don't need this contacts, so I'm going to suppress, or I can just delete this part. So I don't need that one. So this body interaction is going to automatically identify and detect the bodies in contact with each other. Okay, and we can have several different types. You are familiar with this. frictionless, frictional, and reinforcement. To be easy and very fast, I'm going to select frictionless. Okay, and also I need to take care of rebars inside this concrete bar. So let's add one more body interaction, and I'm going to say we are going to have reinforcement option there. So ANSYS is going to automatically say if the object, like a rebars, this rebars inside another object, I'm going to consider as a reinforcement. So basically they designed this exactly for this application. If one of them was inside the other one, it is going to work as a reinforcement. And the other one for the connections between the support and this one, which is going to apply force. Okay, let's go and generate mesh. Okay, because usually this calculation will take is time consuming. I don't want this many mesh here, so let me decrease the quality of mesh. So select this one, control this. I'm going to apply sizing and say let's go with 9 millimeter and see if it's the mesh number is going to decrease. Yes, so we have less number of mesh. And also I'm going to select this one, and again sizing, let's go again with 9 millimeter and generate mesh. Okay, a little bit better. If you want to have more details, I suggest you have an imprint here at this area over the supports and have a much finer mesh close to this area. But I don't want to spend that much time for simulation because I did once and it took me about 2-3 hours to finish the simulation. So this is a video and I want you to do it very fast without that much spending time and finish the workshop. Okay. Oh, by the way, did you see when I create a mesh it took a bit time? If you want to make sure you are using all the CPU cores you have, you can go here, solve process setting, and advance maximum number of utilized cores. Depends on the number of CPU cores you have, you can change this number. 2, 3, 4, 5, 7, depends how many CPU cores you have available. So I already increased this to 4 to be a bit faster. And even if you want to increase the meshing speed, you can come to the meshing part, and the number of CPU for meshing you can increase this. For example, let's go with 3. Or the number of CPU for parallel meshing, you can increase it to 3. Okay, anyway. Okay, let's close this. Let's check the initial conditions and insert velocity. Which object? I'm going to select this one, apply geometry, and I want to have a component based on the direction, so it is going to be negative y, positive y direction. So positive y direction, the unit is millimeter per second, so if I want to be 8 meter per second, it is going to be 8,000 millimeter per second. And you can see the arrow here, it's downwards. Okay, so we have this velocity, and it's going to impact all of a sudden this concrete bar. Let's go for analysis setting. Here it says what is the end time. I'm going to say 5 times 10 power minus 3. So based on this is the end time, which means we are going to have very fast process, and because it's very fast, we are going to have very small delta t, and our time step is going to be very small, and that is why we are using explicit dynamic method. Implicit, we can go larger time step, but for the dynamic process, automatically we need to have very small delta t to capture all the movements, all the details of the simulation. Okay, so you understand this. That is why I selected very small end time, and the delta t is going to be even smaller than that. Let me put this supports there. Fix support for this one, control key this one. So these are going to be fixed support. When we have a velocity for this, for the top side, it is going to crash this concrete bar. What else? Let's go back to analysis setting. Now you can change some stuff here. For example, for erosion control, you can say if a piece of material failed, which means because of that impact, the stress increased over the yield stress, get rid of that stress, and get rid of that material. And if I turn on this, it is going to drop that material. It's part of material failure. You can turn this on or off and check the effect. Let's increase the quality of output. Currently the number of results is 20. Let's go for 50. Even 100 would be better. Yeah. And the result, let's start with deformation. So we defined everything, and let's solve it. Let's click solution information. Now it is going to show us how long it is going to take to solve this problem. 45 minutes. I already waited 45 minutes to have this simulation, so I'm going to stop this. And close this one. This one, the previous explicit dynamic simulation is ready for us to check the results. Okay, let me show all the parts. Okay, this is our geometry, and also let me delete all the information we have here. So we waited 45 minutes, and this is our result for total deformation. We have deformation here, high deformation at the two ends, and lower deformation at the center. and as we can see, a little bit mesh size is very coarse, and we could have better mesh size, but yeah, 45 minutes was already more than we could spend for the workshop. So let me insert stress and check stress. So by impact from above, we can see that the highest stress is at the bottom of this concrete, and it seems the impact wasn't high enough for the concrete to start showing failure. If we had a failure, we're supposed to lose some of these elements, because I turned on the failure mode. So the highest stress is going to be at around the center. Also, we have some stresses close to the supports, and this stress moves upward this area. So the possibility of creating crack is going to be at the bottom, at the area of impact, and like a 45-degree around this support for the left side and right side. And you can see, because the supports and the force wasn't exactly at the center and wasn't symmetric, the results are not symmetrical. Okay. Also, I want to show you damage. To create damage, damage information is not part of the one you can select from here. So you need to go to worksheet. We already worked with the worksheet, and so you are a little bit familiar. Let's see, where is damage? Damage is here. So right click, create user defined result, and solve it. Let's see damage. If the damage value was 1, it means total failure and completely damaged. 0, no failure and no damage at all. So any number between is going to be the percentage of the damage. So as you can see, the highest damage is going to be area under this impacting tool, and it gradually grows to the left and right side. And at the back we have very higher damage. Also, we have damage close to the right support. So if we really had this slab with this geometrical arrangement, we are going to see some cracks, a lot of crack here and from the right side. And the highest is 0.2 damage. Okay, let's see rebars and then finish it. So let me hide these. These are our rebars. Let's select box select. So come on. Because I didn't, this is face selection, I need to go for edge selection. Now it is going to select all the bars, and I want to find total deformation for the rebars. Let's solve it, and you can see total deformation here. On the right side we have more deformation of the rebars than the left side. At the center we have less deformation, and it's about 2.2 millimeter on the right side, and it's the maximum deformation. Okay, let's bring back our parts. Show. This is damage. let's create a video and see how the counter of damage changed because of this impact over the concrete, reinforced concrete.